What would happen if you took a volume of water exactly the size of our sun and dumped it directly onto the star? On Earth, the logic is simple. If you have a massive forest fire, you drop a lake's worth of water from a helicopter to put it out. So you might naturally assume that dropping an ocean of water on the sun would extinguish it. But a campfire burns through chemical combustion. It requires heat to break the molecular bonds in the wood and oxygen from the air to react with those newly freed carbon atoms. Water simply cools the wood so those bonds can't break and smothers the fuel to block the oxygen. The sun, however, is not actually on fire. It is a gargantuan ball of hydrogen gas continuously collapsing under its own immense weight. Deep inside the core, extreme gravity creates a crushing pressure. This pressure is so intense, it forces the nuclei of hydrogen atoms to slam together and fuse into heavier helium atoms, releasing a massive burst of energy in the process. Because the sun is powered by gravitational crushing instead of chemical combustion, the earthly rules of water and fire are completely inverted in space. When our giant bucket of water collides with the sun, we have to look at the math. Water is roughly 70% as dense as the sun's plasma, so dropping that exact volume onto the star doesn't smother it. Instead, it instantly increases the sun's total mass by 1.7 times. To understand what that extra weight does, we have to look at a mechanism called hydrostatic equilibrium. A star is essentially a perpetual tug of war. Gravity pulls the mass inward, while the energy from nuclear fusion pushes outward, keeping the entire system perfectly balanced. But a sudden injection of 1.7 solar masses acts exclusively on the gravity side of the equation, violently disrupting the sun's equilibrium. Gravity squeezes the star much tighter, which in turn forces the core to generate aggressive amounts of fusion energy to push back. Throwing water on a star acts as a gravitational amplifier. It forces the core to crush itself even harder. But what physically happens to all those H2O molecules when they hit a plasma environment millions of degrees hot? They undergo thermal dissociation. The temperatures are so extreme that the water instantly vaporizes, and the molecular bonds are violently ripped apart into free hydrogen and oxygen atoms. Oxygen is much heavier than hydrogen or helium. Because of that density, those oxygen atoms sink rapidly through the plasma toward the center of the star, forming a dense new layer just outside the core. Meanwhile, all those newly freed hydrogen atoms are absorbed by the star, and hydrogen happens to be the exact elemental fuel the sun uses to run its nuclear reactor. This chart shows the binding energy per nuclear particle. If you look at the steep drop on the left side, from hydrogen down toward helium and carbon, you can see how fusing these extremely light elements together releases massive amounts of energy. By throwing a sun-sized ocean onto our star, you haven't put it out. You've simultaneously increased the crushing pressure of its gravity and handed it an entire ocean of fresh nuclear fuel. Down in the core, the sun is now fighting to survive the crushing weight of its new mass. To keep from collapsing entirely, the fusion reaction kicks into overdrive. In astrophysics, there's a concept called the mass-luminosity relation. A star's energy output does not scale in a simple one-to-one straight line with its mass. For a star like ours, total energy output is proportional to the fourth power of its mass. This means a relatively small bump in weight causes an extreme exponential multiplier in brightness. Burning that hot and that bright comes at a severe chronological cost. Instead of lasting another 5 billion years, the sun would rip through its main sequence lifespan in roughly 3 billion years. And here on Earth, the consequences would be immediate. The sun's energy output would essentially triple, instantly turning our planet into a boiled, uninhabitable rock. In the cosmos, mass and gravity dictate all the rules. The ultimate fire extinguisher on Earth is nothing more than hyper-dense star fuel in space.